All right, we're going to do number 6. I'm sorry, not number 6. We're doing number 57, chapter 6. In this case, you have a block against a vertical wall, and you're applying a force. Essentially, you're pushing on it right here. You're pushing on it with 12 newtons at an angle of 30 degrees. We want to know, is the block going to move up, down, or just stay fixed at that position? That's what we have to figure out. So it's to determine, what we really have to do is figure out how much force is in each direction, and that'll tell us what the outcome is going to be. So we always start with the same thing. We have to have a free body diagram. So let's do a free body diagram on our block. So here we have gravity going down. So this is mg. We have a normal force, but the normal force is perpendicular to the wall, so the normal force is coming out this way. Then we have our force, I'm just going to call F our applied force here, at the angle of 30 degrees. We're going to make these our axes because it's going to be moving in the y-axis, either up or down. Okay? All right, then we also have friction. But we don't know which way friction is going. If the block is moving down, friction would be going up. If the block is moving up, friction would be going down. So before I can put friction on my free body diagram, I actually have to figure out which way the block is intending to move. Okay? Then we will put friction in. So what I'm going to do is I'm just doing a quick thing here. I'm going to go to step 2. I'm going to break F into components. So I have F cosine 30 degrees in this direction, and F sine of 30 degrees in this direction. So what I'm going to do is just see, I want to compare F sine of 30 versus gravity. If this is bigger than gravity, then it's going to try to want to go up. If this is less than gravity, it's going to try to want to go down. So I'm just going to compare those values. So I'm going to do this. I'm going to do F sine 30 and mg. And I want to figure out if this is less than, greater than, or equals to. But I have these values. I have F. F is 12. So I have 12 times the sine of 30. And over here I have this is 1 times 9.8. So this side is just 9.8. 12 times sine of 30 should be equal to, what is 12 times sine of 30? 6. Oh yeah, sine of 30 is a half. So this is 6. All right. So this is less than that. What's that mean? That means that gravity, the force of gravity, is stronger than this. So the block is going to try to go down. Okay? So the block wants to try to go down, but then we have friction holding it in place. We call that static friction. So on my free body diagram here, I have static friction going up. Now we have to determine if static friction plus that component of the force is greater than gravity. If those two are greater than gravity, it's not going to move. So that what we're going to do now is our F net y. And that's going to be F sine 30 plus the static friction minus mg. Okay. And so what I really have to do is figure out, are these two forces bigger than this force? So I'm going to do the same thing again. I'm not going to do this as equals. This is just F net y direction. I'm going to say, is mg bigger than, less than, or equal to F sine 30 plus the friction force, but I'm going to replace the friction force with mu sub s times n. Okay? And then I have to do F net x to figure out the normal force, and that's going to be normal force minus F cosine 30. Or this is going to be 0, so the normal force is equal to F cosine 30. I'm going to plug that in for that, and I'm going to get mg is going to be F sine 30 plus mu sub s F cosine 30. So now we got to figure out, if this is not bigger than this, then it's not going to move. If this is bigger than this, and we want to figure out how fast it's moving, we have to switch it to kinetic. But first we got to see if it's going to move. So we know this is just equal to 9.8. That's 1 times 9.8. We know the friction force is 12. And notice I can factor that out. So that's 12 then times sine of 30 plus mu sub s is 0.5 cosine 30. And when I get that, when I calculate that, I get that 12 times sine of 30 plus 0.5 cosine 30 is 11.196. These are newtons. All right, so 9.8 is less than the force necessary to overcome static friction. So what's that mean? It doesn't move. So all you're doing with your 12 Newton force is actually holding it against the wall. It's not moving up, it's not moving down. To move it up, you'd have to push much harder. For it to go down, you'd have to push less. But it's not going to move at that point. Remember, static friction. This is a good conceptual thing here. People get confused. They think, oh, static friction, this is greater than that, so it must be moving up. No, static friction can never make anything move. Friction can never make anything move. And so we already know that gravity is greater than the component up here, so it can't move it up. It's static friction just keeping it from moving. Remember, friction can never make anything move. All right.